Come light it up, I'm ready to go. Come light it up, come light it up, I'm ready to go. Come light it up.
So yesterday you heard from our CEO, Justin Borgman, covering some of the challenges around AI and analytics. And today I thought we'd jump into a little bit more around the analytics challenges and some that are specific to what we are trying to help you with here at Starburst. Now, in order to do this, I want to take a little bit of a sidestep into the operational database space where I actually spent most of my career prior to joining Starburst. In the operational database space, obviously from the start, there were databases like Oracle, like Informix, like DB2, like SQL Server. And over time, you saw the rise of operational databases, really starting with MySQL, you have Postgres, you have MongoDB. And over time, what happened is that everyone basically voted with their feet and went with PostgreSQL. I shouldn't say everyone. There's a lot of love out there, obviously still for MongoDB and MySQL. But PostgreSQL is definitely the most loved database out there. And we see this in survey again, for example, from Stack Overflow. So PostgreSQL is the most loved database out there today. Now, the question is, why? Why did the move happen from proprietary databases towards open source databases and finally Postgres? And it's obviously starts with a pretty simple answer. It's around licensing costs. You had to pay for something like Oracle or SQL Server where MySQL was free. But over time, it's also become about optionality and really the switching costs. If you're building an app on a proprietary system today, a proprietary database, what does it cost to get off? What do you need to do? Well, you're locked into proprietary APIs, proprietary network protocols, proprietary drivers, if you will. Depending on what type of system, typically your data is also locked into proprietary file formats. And moving off of these can literally take years. So you have to adjust your app and typically have to run multiple databases at the same time. So both systems while you're switching over. So that obviously becomes costly both from an operational perspective as well as the programming switching costs, if you will. Now, the same challenge obviously applies also to analytical platforms. What happens if I'm building my data warehouse or my analytical application on top of a proprietary analytics platform? Well, if I want to move, I have to go through the same thing, right? There are proprietary APIs, network protocols, drivers. Now, the data may or may not be locked in. More and more analytics platforms out there support open formats like Iceberg or Delta. But for sure, most of them are still based on proprietary formats. So you have to get your data out and you end up in the same place. You have to change all of your apps and dashboards and you have to run multiple systems at the same time. A question to ask ourselves is, which is going to be the winning platform for analytics, right? So Postgres won, at least for now, and I would say the foreseeable future, the operational database battle, if you will. And Sanjeev Mohan, who is, or used to work at Gartner as an analyst and is now an author, blogger, he has looked into this and he actually posed a question last week, which is Trino the PostgreSQL of analytics? And I think it's a good question, and obviously somewhat selfishly from my perspective, we obviously love Trino here and we're seeing a huge growing community around Trino. And if you're building on Trino, you're building on an open API, an actual open source engine where a ton of investment from Starburst as well as other companies are going in to make that engine better every day, supporting multiple file formats like Hoodie, Delta, and obviously Iceberg, where I think most of us are spending the most time these days. So if you're building your analytics platform, if you will, on top of Trino, well, now you have an easy migration because you can always choose to continue simply running on Trino and bet on the right vendor that gives you the best possible Trino experience. So why does this matter to you? Well, that's exactly what it's all about, is what's your power, if you will, if you want to switch vendor. And when you look at us from a Starburst perspective, we obviously want to make sure that you pick us. And the best way to do that is to provide you an awesome experience, great price performance, and the features that you expect from an analytics platform. But what's very important to note is if you're building on Trino, all of your apps are using the Trino APIs, all of your apps are using the Trino SQL dialect. So if, for example, Starburst decides, we're going to increase our prices and it's not worth it anymore to buy from us, you can go buy Trino and including support from someone else, or maybe run it yourself and employ a set of data engineers or software engineers and set up the system and run it. So you're in a much, much better place betting on an open platform like Trino. And like Sanjeev said, I think it's a good question to ask, is Trino the PostgreSQL of analytics? So jumping in a little bit more to what we are doing here at Starburst. Now, obviously, Justin introduced you to the open hybrid Lakehouse yesterday and went through our platform where we are doing investments. And I thought we would step in a little bit more to the data access part, like I mentioned when I started, and talk about how is this different? How is using Trino and the Starburst platform different from betting on something else? And I would say the fundamental thing for us is really ease of use. We want you as productive as possible. So if we take an example, I'm building a dashboard or an application, and we have some of our data in the lake. We have a lake, and we're using Starburst product to query and work with this lake and secure the lake and so on. And now we realize, okay, we're building a new dashboard and I need some data that's not yet in the lake. And this is kind of where the magic starts. You can start with directly connecting your Trino instance to the data sources you need the data from. So it could be Oracle, could be SQL Server, could be MySQL, Postgres, or whatnot. And you can actually explore and query that data directly from your analytics platform. Now, what's interesting to note there is you can actually build the whole app and build the whole experience without moving any data. You're querying using Trino, but directly into your source system. Once you have the dashboard or application set up and you have the data you need, now you can take the second step and optimize this and create what we call a data product, where we can materialize this data automatically for you inside the lake and make sure you have the highest levels of performance in your dashboard or application. Now, to show this, we're going to have Emma from the team go through a demo of Starburst Galaxy, getting data from another system and building a data product that then can be used to power your applications. Over to you, Emma.
In this demo, I'm going to show how easy it is to discover, federate, and share data in Starburst Galaxy. In this demo specifically, what I'm looking to do is combine web login activities with customer data so that my fraud analyst can easily investigate and determine whether fraudulent activities occurred in March of 2024. In order to do that, I will need to join data from my Amazon S3 bucket with my PostgreSQL table. I don't know the exact path of where my login data lives though, so let's go ahead and use Starburst Galaxy's universal search to find the correct table. I'm going to click into my login actions catalog, move down, and I see that I have a login attempts schema. So let's click in there, and I see a login actions silver table. Okay, now using the catalog discovery, I can see that we have all of the correct columns that I'm looking for. I was looking for customer key. I know that's what I need to join with my PostgreSQL table. I also see login attempts, login dates. This is looking correct. But let's go ahead and verify that the data in this table is also what I expect it to be. Okay, using a simple select statement, I'm able to see that all of the different columns are populating as expected, and I can see the different login attempts. I can see whether those logins were successful or not, and I can see when they occurred. Now, I do need to join this information with more customer details in order for my fraud analyst to successfully investigate and identify those fraudulent actions. So I'm going to go ahead and try to find the correct customer table. I know that I have a lot of different customer tables, but what I do know is that this specific customer table is stored in Postgres. So I'm going to use universal searches filter functionality over here to filter to my PostgreSQL customer tables. I also know it's stored within our burst bank with stats location. So I'm going to go ahead and click into this table, and I'm going to query this data with a simple select statement as well, just to verify that I'm returning the right information. Perfect. Now I can see that we do have the correct customer key column that I was looking to join on, as well as the first and last names of all the customers and the relevant location and contact information that my fraud analysts need. All right, so now let's go ahead and run a simple federated query to join the two tables. You can see here that I'm simply running a select statement with a couple inner joins between my login actions in S3 and my customer data in Postgres. And perfect, that was successful. So I can see that I now have my login attempts joined with all of that customer data, including the contact information, the customer segment, risk appetite, and more. But my fraud analyst did mention that they don't want all of this data. They wanted to limit it only to customers that have experienced 5 or more login attempts in March of 2024. So let's go ahead and just add a simple where clause to our original SQL statement to filter down these results even more. Great. Now I can see that we are only filtered down to a limited set of customers. Okay, now that I have the results that I want and everything's looking correct, I'm going to go ahead and promote this to a data product. Data products allow me to attach relevant business metadata to my data set so that my analysts know that this data can be trusted and has been verified. We're going to go ahead and click Create New Data Product. I'm going to store this in our Logins Actions catalog, and I'm going to call this Fraud Logins March. We're going to hit Save and Continue. And now I'm going to go ahead and name my data product. I'm going to call this Financial Analytics March 2024, and we're going to say this is version 3. Now, I can add a little summary and description about my data products. I'm going to say that this is suspicious login attempts in March 2024, and I'm going to say this combines customer profile data with login activity. Great. Now I can add some supporting information, including links, but I'm going to go ahead and minimize that out in the interest of time. And the great thing about this is I can assign this data product to a contact within Starburst Galaxy. This really allows those business analysts to understand who to reach out to very quickly if they have questions about this data set. Okay, great. Now we're going to go ahead and confirm the data set. So let's run and preview the data. And this looks right to me. I'm going to close the data set preview, and I'm going to go ahead and save this as a materialized view because I want repeatable performance for my analysts. I'm going to name this Fraud Logins V2, and we're going to schedule a refresh every hour on the hour. Easy. Now let's go ahead and create our data product. Great. Now I can see that I have my data product created here. We have the suspected fraudulent logons. I have the right data sets, and we can even add usage examples in the future. That's how easy it is to discover my data across 2 different tables, create a federated query, and go ahead and promote that federated query to a materialized data set on my data lake with Starburst Galaxy. Thank you.
Awesome. Thank you, Emma. Now, normally at this part of the presentation, I would remind you that what Emma just showed us is a demo, and it's coming soon, maybe 6, maybe 12 months. But the best part is that what Emma just built and ran actually was live in our production environment in Starburst Galaxy today. So, go try it out. Now, companies all around the world are taking advantage of our open hybrid Lakehouse platform, and they're seeing awesome results. A good example of this is one of our customers HSBC, and they actually recently won the Hong Kong Business Magazine Technology Excellence Award for their standout AI and data initiatives. They've been relying on an outdated on-prem data lake for everything from product recommendations to risk profiles. But that lake was slow and inefficient. Analytics took hours, data copying was inconsistent, and engineers were wasting time and storage. HSBC wanted to streamline data processing, meet data sovereignty rules, and future-proof their infrastructure. So they built a virtual data lake in the cloud using Starburst. Now, this move to the cloud and to Starburst reduced data movement, it boosted their efficiency, it cut their costs, and it ensured compliance across all data sources. The most exciting result for me was that they were able to reduce the time needed to generate insights from data from an hour to under 3 minutes. That's about 20 times faster queries than in their legacy solutions. So today, I'm excited to announce a slew of new capabilities that will continue to bring success stories like HSBC's to life. First and foremost, we're super excited to announce the next generation caching available in Starburst Galaxy. This caching will combine the power of our existing warp speed technology and its smart indexing and caching capabilities to intermediate workload results. Warp speed will now be able to identify patterns of similar subqueries across multiple workloads and be able to use these to optimize the performance of the queries. This will greatly increase the scalability and stability of queries running on top of Starburst Galaxy for both BI, dashboarding, and other workloads. Now, in addition, we've now enabled enhanced autoscaling in Galaxy. The new autoscaler doesn't just monitor CPU. In fact, now we've expanded it and it monitors CPU, memory, and number of queries in queue. It also provisions additional compute resources about 50% faster than before, giving you the resources you need for faster query execution and eliminating the wait for resources and the need to manually manage and remove resources. Finally, we're also adding policy-based routing. And policy-based routing makes it so that you can programmatically route your queries to the appropriate Galaxy cluster based on some predetermined set of rules. This will allow you to guarantee that resource-intensive queries are executed by certain clusters that may need to run something like fault-tolerant execution, while other queries that need interactive results and benefit from warp speed can be executed by other clusters. Building on this, the next thing I want to talk about is our data ingestion capability. Now, what we looked at so far is all around how do you improve the performance and experience for queries running against existing data in your lake, as well as how did you bring in new data into your lake. But what if you want the lake to be updated and looking constantly at fresh data? Well, then obviously you need to start ingesting data directly into the lake. We looked at a few features related to making your existing lake faster, easier to use, and so on. Now, what about landing data in the lake? And actually landing data in the lake so that you can look at it as it lands and getting more of a near real-time experience on the lake. This is something that's, I would say, a fairly complex topic. It can be very time-consuming. Typically, you have to stitch together a lot of different tools to make this work. It's built typically on inflexible infrastructure. Sometimes the data lands in one format. You need to convert it to the format you would like the data in. And you also need to optimize the data so that it performs better when you actually want to read it and build apps or reports on top of it. So I'm excited to announce the general availability of our streaming ingestion capability. We public previewed this earlier this year, and now with Datanova, it's generally available. And what is this? Well, fundamentally, it's all about getting your data from your application, and in this case, from a Kafka topic directly into the lake so that you can query it. And what we've focused on is really 3 pillars here. It needs to be easy, it needs to be cost effective, and it needs to scale. And so In terms of starting with the easy, you'll see this in a demo from my friend Matt Fuller in a bit. On the cost effectiveness side, it needs to be as low cost as possible so that you can ingest a lot of data. And the scaling is obviously about how much data can you get in, the rate of data ingestion, if you will. So we make the data available in near real time. It lands directly in Iceberg tables, and it lands optimized. So you don't need to convert it after it lands, and you don't need to further optimize it. And it guarantees exactly once delivery of the data. The whole thing runs on a serverless architecture, which means you don't have to configure the infrastructure. Now, when it comes to the scaling, we have tested this solution up to 100 gigabytes per second of uncompressed data coming in JSON format. And this is 100 gigabytes per second. It's not across many Kafka topics to many Iceberg tables. It is one single Kafka topic to one single Iceberg table. And we can land up to 100 gigabytes a second. That's about 3 petabytes, I think, 1 petabyte every 3 hours or so. And we can land it there at less than half the cost of alternative solutions. So let's take a look at how this actually works to set up and how easy it is. Literally starting from picking your Kafka topic and discovering what the data looks like, and then landing that data in your Iceberg table. Matt, please show us how this is done.
In this demo, I'm going to show our streaming ingest capability in Starburst Galaxy. And so we have this new concept called data ingest. And in this view, we haven't connected any sources yet, so it's empty. So the first thing we're going to do is we're going to click on Connect New Source, and we're going to choose our source. So we can support Apache Kafka, Confluent Cloud, and Amazon MSK. For this demo, I'm going to choose Confluent Cloud. Click Next. So first what I'm going to do is I'm going to create a new source, and I'm going to give it a name. I'm going to call it Demo. You could give it a description. I'm going to leave it blank. The next thing you want to do is enter in your Kafka brokers. So I'm going to enter that in. So I'm going to paste in the Kafka broker. If you have multiple of them, you would separate them by commas. Next is I'm going to enter in the authentication information to the Confluent Cloud cluster. So I'm using the API key and API secret, and then I'm going to click Test. And we were able to successfully connect to the Kafka cluster. So we're going to click Save New Source. The next thing we're going to do is we're going to select the topic to create the Iceberg table from that we call live tables. We're going to select the catalog. So I have one pre-configured called Icehouse. This will create Iceberg tables on S3. I'm going to choose a schema. I'm going to call this streaming ingest. I'd already created that. And we're going to give it a table name. I'm going to call it stock trades because we are going to be reading data from an example stock trades topic through that's coming from Confluence example stock trades topic. So we're going to choose stock trades as the topic. We also have data retention. Here you can specify a retention threshold. Say you want the data to be expired after 90 days. You could choose that. I'm going to leave it as retain forever. And then we also have the ability to choose different throughput limits per partition. So I'm going to keep the selected 8 megabytes a second per partition, but there are other options as well as you size your system with your throughput requirements. And then last, I'm going to choose a starting point. We can start from the latest messages, or we can start from the earliest messages. That means starting from the latest messages, any new messages we're going to ingest, but anything that's previously on your Kafka topic won't be ingested. If you do this, we're going to go back into the retention period of Kafka and ingest those as well. So I'm going to do this because you're gonna see how we are able to backfill those messages into the Iceberg table as well as ingest new messages. I'm going to click Test Connection. and we're able to successfully connect. So what we've done so far is we've connected to the Kafka cluster, and now we've set up where we want the table to land. So we're going to click Create Target. In this last piece here is we're specifying a mapping between the messages from the Kafka topic to how we want it to appear in the Iceberg table. So on the Kafka topic, they are sending JSON messages. We can see here in the message sample, and we're automatically inferring a schema from that JSON data as shown here in the mapping. So we have the JSON path to a column name and then the data types. So you could change these, say you wanted the column names to be different, or you have some domain knowledge about the data where you want to adjust the types, or maybe you don't want a particular column to be ingested. You can choose that. I'm going to leave the default. So I'm going to click Create Live Table, and you see that it's being created here. It takes just a few seconds to start. One thing I also want to note is now that we've set up Kafka connection, if there are other topics from that Kafka cluster that you want to load, you don't have to re-enter the Kafka credentials. You can simply just go to Create Live Table and choose your new topic. But I'm going to go back. We can see that what we just created was running. So let's query the data. And there you have it. In just a few minutes, we were able to connect to Kafka, configure the topic that we want to ingest data from into an Iceberg table. And running this query, you see that we've inserted 990. And from running this query, you see that we've inserted 990,000 rows approximately. And so I ran the query again, and you can see that we're continuously loading data in. Now we have about 1.3 million rows. So this table is continuously being loaded by from Kafka into the Iceberg table. So that's what I wanted to show for the demo. Thank you.
Awesome. Thank you, Matt. That's awesome. Now, if you want to learn a little bit more in depth about this capability, and maybe nerd out a little bit, you can listen to Matt and Eric Wang as they go through a session in depth about the streaming ingestion capability, a little bit more technical details around how it was built, and how you can leverage it to build your solution. I think it's important to note again, these are completely regular Iceberg tables. So obviously I would prefer if you use a Starburst product to query it, but you could literally use any product that can read Iceberg tables to query this data. In terms of what's coming soon, we should also mention something, and there's quite a lot, I would say, cooking across Starburst, both in the ingestion space and other places. One thing I wanted to talk about, which is coming relatively soon, is our file loader. So in this demo, this example was all powered by ingesting data from a Kafka topic. Another very common ask that we hear from customers is simply ingesting files that land in an S3 bucket. So that's also something that we're working on, where you can basically point us at some S3 bucket, and when new files land, we automatically parse them and ingest them, much like the Kafka topic, and it lands in your Iceberg table fully optimized. And again, we do all of the maintenance, vacuuming, and so on of those Iceberg tables. So that's coming soon. Now, I want to thank all of you for listening. Hopefully you have an awesome Datanova. I would, again, highly recommend going to Eric and Matt's talk. I think it's going to be a blast. And please try out Galaxy. Please come ask us for questions. And we hope to be able to help you with your analytics, Iceberg, both ingesting data in near real time, as well as querying any data that sits in your data lake. Thank you so much. Bye.